That was just how it was done. The gospel, really. But then, things started to get weird. Around a decade ago, the old rules just stopped working. This is where our whole story takes a sharp turn. Because with the rise of deep learning, that neat and tidy balancing act we just talked about, it got completely thrown out the window. And this leads us to a much deeper and honestly, a way more interesting question for today's AI. Is the real problem that these models are learning too much? Okay, so here's the central mystery. Modern AI models are just huge. They're massively over-parameterized. That's a fancy way of saying they have way more knobs to turn, parameters, than they have examples to learn from. I'm talking billions of parameters. Now, according to all the old rules, these things should be the absolute worst overfitters imaginable. They should be completely useless on anything new. But they're not. They're actually amazing at it. So what is going on? Well, this huge contradiction forced researchers to dig deeper, and what they found was bizarre. It's a totally counterintuitive phenomenon that just flipped our whole under. This is where we get to the double descent twist. So let me just throw a crazy idea out there. What if the whole sweet spot thing was wrong? What if the way to get a better model wasn't to avoid overfitting, but to lean into it, to blow right past that overfitting peak and just keep making the model even more complex? Okay, check this out. This graph shows something that just shouldn't happen according to the old rules. This is the double descent curve. Just follow the line for test error. As you make the model more complex, moving from left to right, the error goes down. Great. Then it hits that point where it shoots back up. That's that classic overfitting peak we talked about, right where performance gets terrible. But, and here's the wild part, if you keep going, if you make the model even more complex, the error starts to go down again. A second descent. It's incredible. So how on earth is that possible? Well, the leading theory is that when a model gets this big, this over-parameterized, it actually gets a new superpower. It has so much capacity that it can basically do two things at once. Part of the model is dedicated to just brute force memorizing every single detail of the training data, noise and all. But then it uses the rest of its enormous brain power to build a much smoother, more general version of the world that can actually tell the difference between the real information and all that noise it memorized. This whole double descent discovery just blew the doors open on a new way of thinking. It turns out, learning doesn't just stop when the model starts overfitting. In fact, for these huge models, that's when some of the real magic starts to happen. This is what we're calling learning after overfitting. And researchers found an amazing word for this. They call it grokking. It's straight out of science fiction. Grokking is this bizarre moment where a model has already achieved 100% on its training data, it's totally overfit, but you keep training it anyway. And then suddenly, out of nowhere, it's like a light bulb goes off. Its ability to handle new data just skyrockets.